Okay, I think we're good again. All right, so the first thing we're going to start with is to define what a function is. All right, so you guys did talk a little bit about this last year, and you were able to go through and look at some different equations and determine if it is a function or not. But does anybody remember what it actually means to be a function? Yeah.
Each x has only one y.
Correct. Yeah. So that's kind of the x and y version of it. Each x has exactly one y. Another way of looking at it, because we don't always have functions that involve x and y. Maybe it's like t and m or something. We could use other variables. So the x we think of as the input, and the y is the output. Okay. So thinking about it with x and y like that, it's not a bad thing, because oftentimes that's how we're looking at functions with x and y. But it's more of an input-output thing in general, though. Okay. So we say there's one output for each input. Like, do you guys remember, I don't know if they were doing this still when you were in elementary school, but those input-output boxes, did you guys do that in math class, like in 5th grade or something like that? Okay. You were learning about functions and you didn't really know it at that point. That's what those were, the input-output boxes, and you're trying to figure out what's the rule or whatever that works if you put this in and you get that out and that sort of thing. That's exactly what that was, though. It's talking about a function. Okay, so now graphically, how did you guys check for functions on a graph? Vertical line test, exactly. So, say it must pass the vertical line test. Okay, and so that's that same exact thing of if it doesn't pass the vertical line test, then you're getting two outputs for one input, and it's no longer a function. Okay, so like if I'm going to do just two quick little graphs here, and we're going to see if we can determine which one's a function and which one's not. Okay, so the first one. Does that pass the vertical line test? Yeah, it does. The vertical line test is you drop a vertical line in it and you make sure that it only ever hits one time, and then it passes. So, yeah, any vertical line that I would drop through this thing, no matter where I do it, each time it's only ever going to hit the function once. Okay, so this is a function. Okay, now what about the second one? Does that pass the vertical line test? No. Okay, are there certain places on that function where it does pass the vertical line test? Yeah, there are certain places where it does, but does every x value work? No. I can find a specific place where it doesn't work. Okay, so for this specific input right here, I'm getting 1, 2, 3 outputs. Okay, and that does not fit the definition of a function then, so that's not a function. Okay, so graphically that's how you can check it out, and we'll be doing a bit of that. Okay, so we're going to move ahead here to domain and range. So what is a domain? Does anybody remember that from Algebra 2? Yeah.
All the possible x values.
Good. Yep, it's all the possible x values that a function could have. Another way of looking at that, they are inputs that work. Okay, that's what we're going to be really dealing with when we're trying to calculate a domain for a particular function, is what numbers, when I plug them in, actually work. Okay, so let's try that for just a second. So if I get f of x equals the square root of x, there are certain numbers that I can plug into this function and it will give me an answer. And there are certain numbers that I plug into this function and it will not give me an answer. Okay? So what are the numbers that work with the square root? What ones am I allowed to plug in? Positive? Squares? Square numbers will work. Okay, that'll give me an integer answer. But I could still plug in, like 3 is still okay, right? It's not a perfect square, but square root of 3 is still a number, right? Anything that's positive, or there's one other number that's not technically positive that still works. 0, right? So the square root, as long as it's not a negative number, right, I'm good. So the domain for this would be all, I'm just going to say non-negative numbers. All right. Mathematicians don't really like to write things out in words, so we can write this a different way. Okay? So instead of writing the word domain, just do the letter D with a colon next to it. Okay, so our domain is, and instead of writing all non-negative numbers, you can do that as an inequality. Okay, so the domain is x and or equal to 0. Does that not describe the same thing? Any number greater than or equal to 0 is non-negative, right? Yeah, so we can do it like that. Now, I'm going to teach you guys a different way to do domain here, a different way to write that inequality for domain that is a little bit more the standard as you move into upper level math, and that's called interval notation. Okay, so I want to kind of pause this domain discussion for a second and talk about interval notation so we can start using it with it. So the way that interval notation works, basically it's a way to take anything that's an inequality and write it in a more concise way. So, and it describes an interval. So, keep breaking my lead. If you use parentheses, you don't include the numbers. And I'll give you some examples here in just a minute to help explain what this is saying here. But just want you to write this down first. If you use the brackets, you do include the numbers. Okay, so let's say I've got the inequality -3 less than or equal to x less than or equal to 5. Okay, we call that a compound inequality, right? And that means that x can be any number in between -3 and 5. And when I have the or equal to bars underneath there, that means it could be -3, it could be 5, right? It includes those two numbers. To turn this into an interval notation instead, it would look like this. put a bracket, -3, 5, bracket. And there's a comma in between. So that means it's the interval from -3 to 5, and because I'm using the brackets, I am including those two numbers. Okay? What if I had -3 less than x less than or equal to 5? So how would that change the interval notation then? Well, up here I said you use parentheses if you're not including the numbers. You use brackets if you do. So what's going to be the only change here? Yeah, the left bracket's going to be a left parenthesis now. So parenthesis, -3 to 5, bracket, like that. And if they were both just less than symbols, then you'd have parentheses on both of them, that sort of thing. Now, this gets a little bit trickier if you've got an inequality that is less than or equal to 2. Okay? Because what are the two numbers? There's only one number. It's just a 2. So x less than 2. Well, what's the upper limit of the interval? 2. It can't go any higher than 2, right? So we know this is a 2, and it's less than or equal to 2, so we put a bracket on that. But what's going to be over here? How far down can it go? It can go infinitely far down, right? Even into the negatives, infinitely far. Okay? So negative infinity is the other one. And I put a parenthesis on there because can you ever get to infinity? No. So can I, it's not an actual number, right? So can I include infinity then? No. So you never put a bracket around an infinity, okay, because it is unattainable. So parenthesis, negative infinity, comma 2, bracket would be that one. Okay. Let's do maybe just one more here, and then we'll start applying this to our domains. What if it was x greater than 1? Take a minute, see if you can write an interval notation for that. X greater than 1. Okay, so what does it look like? Anybody want to be brave? Yeah, go for it. Yes, just like that. So when you have two parentheses on it like that, what does it start to look like? It looks like an ordered pair, right? Like a pair of coordinates. So you got to be careful. Okay, you have to know when you're reading your textbook or whatever, or working on an assignment, in what context are you talking? Are you talking about intervals, or are you talking about points on a coordinate plane? Okay, they look exactly the same sometimes, but it should be clear, based on the context of what you're in, what it is you're actually talking about there. Okay, so all right, well let's do a few more.